Okay, so the last solid we have for Unit 11 and finding volume is finding the volume of spheres. And a lot of the formulas that we're going to use and terminology and vocab is very similar to that of a circle. Because a sphere is just your three-dimensional circle. It's a set of all points in space that are a fixed distance from the center. So you should recognize that that definition is pretty similar to that of a circle. The radius connects the center of the sphere to any point on the surface. And then half of a sphere we call a hemisphere. Right, and using this definition or this vocabulary, we're going to come up with the formula for the volume of a sphere, similar to how we found the volume of a pyramid and a cone, which was just a third of the volume formula for prisms and cylinders. Okay, if you go ahead and open this app, or you can just look on here, it's this GeoGebra link that's on School Agenda Notes. Right now we have on the left, we have a hemisphere, and on the right, we have a cylinder with an inverted cone. Hopefully you can see that inverted cone. And what this is showing when I slide up and down is it's showing this cross section. Sorry, the slider is not working great right now. Showing the cross section of the two areas is exactly the same, okay? Of course, it's not working great right now. But you can try that on your own. Hopefully it works a little bit better for you. But when the cross section of the two areas is the same, let's slide this over now. Let's see, here we go. When the cross section of the two areas is the same, then the volume of the volume of the hemisphere and the cylinder with the inverted cone would be the same. So equal cross-section area means that the two solids have an equal volume. So what we can do then is we can say the volume of this hemisphere equals the volume of the cylinder with the inverted cone, which is this expression right here. And we know the formula for the volume of a cylinder and the volume of a cone. We just talked about those in the previous units. The volume of a cylinder is just pi r squared, area of the base, times the height. And then the volume of a cone is the same formula, but 1/3 area of the base times the height, okay? And we're really left with pi r squared h minus 1/3 pi r squared h. These are like terms. So if this is 1 or 3/3 and we're subtracting 1/3, we're left with 2/3 pi r squared times h. Okay, and then the last thing I'd like us to notice is if we go look at the height of this hemisphere, it's the same as the radius. So then we can just take this height and replace it with the same length, the radius, and now our formula simplifies down to 2/3 pi r squared times r is just r cubed. So this is our formula for the volume of a hemisphere. If we want to find the volume of a sphere, that's just half. We could just multiply by 2, and now we have our formula for the volume of a sphere. 2/3 times 2 is just 4/3 pi r cubed. And you can see that's the same exact formula we have listed here. So for hemisphere, we would be using 2/3. For sphere, we would be using 4/3. All right. Let's go practice using those formulas on a couple of the solids. Let's do A and B together, and then you can try C and D on your own. For A, we have a sphere. So our formula for volume is 4/3 pi r cubed. Probably gonna need calculator back up. The radius is actually given for you right there. The radius is just 9. So volume equals 4/3 pi times 9 cubed. And just punch this into our calculator. 4/3 pi times 9 to the power of 3. Directions say round to the nearest tenth, so we get a volume of 3,053.6 cubic centimeters. Okay. For letter B, we have a hemisphere. It's half of a sphere, so our formula would be volume equals 2/3 pi r cubed. And then again, you're given your radius, so just punch in the 2/3 pi times 11 cubed. 2/3 pi times 11, cubed, and then round to the nearest tenth. Volume equals 2,787.6 cubic inches. Okay, why don't you guys try the same for examples C and D. Remember, 4/3 for volume of a sphere, 2/3 for volume of a hemisphere, half of a sphere. Go ahead and pause the video, work through these two examples, and I'll put the solutions up in just a sec. For C, we should have punched in 4/3 pi 12 cubed. Don't forget we're using 12 because that's our radius, half the diameter. They got in a volume of 7,238. Oh, come on. 7,238.2 cubic inches. And then for D, hemisphere, so we should have used 2/3 pi times 15 cubed, and we would have gotten a volume of 7,068.6 cubic meters. Okay, let's continue a few more examples. Now when we're given the volume and we're asked to find different parts of a sphere or hemisphere. So for E, we're asked to find the radius, and for F, we're asked to find the diameter. Just punch in what you're given for volume, 9,216 pi, and set that equal to whatever volume formula we would be using here. And this is a hemisphere, so that would be 2/3 pi r cubed. And now we're just undoing this problem solving for r. So we need to get rid of the 2/3 and the pi. And because they're being multiplied, we can just divide both of them over. And we would have r cubed by itself. On your calculator, you can just enter 9,216 pi divided by 2/3 pi. And we are left with 13,824. Then just like removing a square by taking the square root, removing a cubed, we would take the cubed root, and on your calculator, the cubed root option's right there, 13,824. We get a radius of 24 feet. All right, let's do the same for F. F, we're asked to find the diameter. And now this time it's for a sphere when you're given the volume of 36,000. So we need to set 36,000 pi equal to 4/3 pi r cubed. Again, divide the 4/3 pi over. We're left with r cubed equals 36,000 pi divided by 4/3 pi. We get 2,700. I'm going to slide this all over. Sorry, we get 27,000 equals r cubed. Take the cubed root of both sides, and we're left with a radius of, let's see, cube root of 27,000, 30. Okay, this is not our answer because we're asked to find diameter, and diameter is the radius doubled, so diameter would be 30 times 2, or 30 plus 30, 60 centimeters. Okay. Last thing I'd like us to finish up with is finding the volume of composite figures. We've done this before on the previous 2 lessons. Let's do the kind of pill-shaped composite figure and letter A together, and then you can try the ice cream cone shape on your own. So hopefully for this pill-shaped solid, you see that we have 2 hemispheres making one whole sphere, and then a cylinder connecting the 2. So volume of the cylinder, pi r squared times your height. And remember, you'll have these formulas to use on the test. Have a nice printed out sheet of these. I'll put that same sheet for you on the test review. And then the volume of the sphere, 4/3. 2 hemispheres makes one full sphere, so we're going to use 4/3 pi r cubed. Okay, radius of the cylinder is the same as the radius of the sphere, so we would have pi times 2 squared times a height of 5. Punch that into our calculator in just a sec. For our sphere, 4/3, same radius of 2, so 2 cubed. We get, let's check both, 4 pi times 5, 62.8, and then 4/3 pi times 2 cubed, which is 8, 33.5. And then just add these 2 volumes together for a total volume of 96.3 cubic feet. Okay, why don't you guys pause the video, work through example B on your own, and I'll put the solutions up a sec. You have a hemisphere and a cone. Okay, hemisphere and cone, so you should be using those 2 volume formulas and then add the volume of each solid together to get the total volume of the composite figure. Okay, pause that video. I'll put the solution up when you're done. For the cone, our formula is 1/3 area of the base. Area of the base is 7 squared, so 49 pi, times the height of 24. Sorry, let's briefly talk about how we got 24. Remember, this is the height of the cone, not the 25. The 25 is this slant height, but we do have a right triangle right here. So if we wanted to find what the actual height is, that would be 25 squared equals 7 squared plus our height squared, just using Pythagorean theorem with this blue right triangle here, okay? 625 equals 49 plus h squared. We get h squared equals, I need our calculator here, 625 minus 49, so 576. And when you take the square root, you should get a height of 24. And we do. Okay, great. And then we need to add the volume of the hemisphere, don't forget for hemisphere, that's 2/3 pi times our radius cubed. When we add both of these together, we get a final volume of 1,949.9 centimeters cubed. Right, and that's really it for this unit. You'll have some homework on this and a homework quiz, and then we will start practicing next week, preparing for your test on Monday. I will have a test review for you guys filled with practice problems and a formula sheet that you should use on the test, just like the same formula sheet you used for chapter 10, which was on perimeter and area. This one will be on all your formulas for volume of the different solids we've talked about this unit. Okay, if you guys have questions, I can answer them during office hours, and I'll see you guys there.